Welcome to Summarize Science. Today, we're looking at a fascinating new paper on AI for breast cancer detection. Advanced 3D mammograms, also known as DBT, are better at finding cancer, but they create a big problem for AI. There isn't much 3D data available to train them. Previous AI solutions had some major trade-offs. As shown in this diagram, some methods would just flatten the 3D scan into a single 2D image, which loses all the critical depth information. Other methods process the scan slice by slice, but this approach struggles to see the full context and often requires clunky steps to piece the results together. This is where the new model, M&M 3D, makes a huge leap forward. The researchers designed an AI that can learn to think in 3D without adding any new, complex components that would require more data. It ingeniously reuses its existing architecture, allowing it to take all the knowledge learned from thousands of 2D mammograms and directly apply it to 3D scans. The model works by interacting with every slice of the 3D scan and then intelligently fusing the information, paying more attention to the slices that look the most suspicious. And the results are visually very clear. Here you can see that a standard 2D model struggles to see the cancer, and a simple projection method still suffers from clutter. But on the far right, M&M 3D successfully pinpoints the malignant finding with a high score, while correctly keeping scores low in other regions. The performance numbers tell an even more impressive story. After fine-tuning, M&M 3D, shown in the bottom rows of these tables, dramatically outperforms the older methods in both cancer detection and classification. It substantially closes the performance gap that previously existed between models for 2D and 3D imaging. However, the most important breakthrough is how well this model performs when data is scarce. These graphs show that even with only 10% of the training data, M&M 3D, the blue line, is significantly better than more complex alternatives that are data-hungry. This data efficiency is a huge deal because the lack of annotated 3D medical data has been the biggest bottleneck in the field. When tested on a popular public challenge dataset, the model set a new record. Even with zero 3D specific training, it performed remarkably well. After training, it achieved the highest performance scores ever reported on this benchmark for both classification and detection. So, let's recap the key takeaway. This research provides a way to build highly accurate 3D cancer detection AI without needing massive, hard-to-get 3D datasets. By being incredibly data efficient, M&M 3D makes advanced AI for 3D breast screening much more accessible. Looking to the future, this design could lead to unified AI models that can analyze both 2D and 3D scans together, and even compare a patient's scans over several years, just like a human radiologist. This is a major step towards making breast cancer screening more powerful and effective for everyone. Thanks for joining us on Summarize Science.